Let's understand the problem. Okay. So YouTube is a video sharing platform, as we all know, and where users can upload, view, and interact with the video content. Okay. So now let's head to the some of the functional requirements. And we have the requirement of the upload videos. This is the first requirement, and the second, we can watch the videos or basically the stream the videos. And there are some out of the scope functionalities like users can view information about a video and such video counts also. Users can search for videos, users can comment on videos, user can see recommended videos, user can make a channel and manage their channel, user can subscribe to channels.
Yeah, I
Okay.
think so. The main requirements we are concerned about here
Hmm.
is the uploading of the video, like how we are going to upload the video, and another one is like user can stream also. So it is
Yeah.
kind of a live streaming or something
Hmm.
that is, but we are not majorly concerned about the view counts and search functionality. So I think the focus of the design should be on uploading
On
and watching of the videos.
videos. Yeah.
Okay, yeah.
It's worth noting that this question is mostly focused to video sharing aspects of YouTube. If you are unsure what features to focus on, like YouTube was similar here. Okay. So I think we should skip this non-functional requirements as uh, okay, let's read it first. The system should be highly available, prioritizing availability or consistency. Yeah. The system holds support for uploading. Yeah.
Yeah. So,
Nagarani, there's a lot of noise coming from your side. Can you please mute?
yeah, sure.
The system should support uploading and streaming videos, basically like tens of GBs. The system should allow low latency streaming of videos even in low bandwidth environments. Okay, the system should scale to a high number of video uploaded and watched per day, which is basically nearly 1 million videos uploaded per day and 100 million videos watched per day.
so basically,
The system should support resumable uploads.
yes, so
Okay.
let's see like so the system should be highly available and
Yeah.
so as per cap theorem like we have to trade off between availability and consistency. So I think it
Yes.
should be highly available because we are live streaming also. So that is why like it should be and then the size of the file should be tens of GB, right? So it can
Yeah.
be a large file and it should be smooth, low latency. This is fine. And the system should also scale to the number of videos uploaded.
Yeah.
So, so basically here we are trying to estimate the scale which we are looking at,
Mm-hmm.
and here mostly there are around 1 million videos uploaded per day, and we are assuming there are 100 million daily active users which are sort of watching the video. So if we see this, then there is a read ratio more than the write
Mm-hmm.
ratio, right? So
Yes.
it is a mostly a read heavy system. So yeah, so I think we are good. We can move on. Yeah.
Yeah. And these are basically the out of scope functionalities, so we don't need to be concerned about these, like the bad content videos or fake account uploading or consuming videos, as well as the monitoring and alerting things. Okay. So for this question, we given the small number of functional requirements, the non-functional requirements are even more important to pin down. They characterize the complexity of these deceptive, simple upload and watch interactions. Enumerating these challenges is important as it will deeply affect your design. Okay. So we are not worrying about the non-functional requirement for the time being, but uh, we should uh, we should also look upon them as well because they will be important in the future.
Yeah, like because our design would depend on the scale, right? So
Yes.
if let's say uh, it's a read heavy system, so the design would be completely different for it.
Mm-hmm.
And even I think we are also supporting large videos around 10 GB, right? And
Yes.
there are 1 million uploads that are happening per day. So if you calculate it right, then
Mm-hmm.
it would be around 10 multiplied by 1 million, and then there is GB. So the data would be huge. So yeah, we need a storage also, which would
Heavy storage. Yeah.
yeah, and the latency at the same time should be low, right? So yeah,
Yeah.
so we need to kind of optimize like how we are uploading the videos, maybe dividing the videos into some chunks or something.
Mm-hmm.
So maybe yeah, let's see how the design goes. Yeah.
Okay. So first of all, planning the approach. Before you move on to designing, though, it's important to start by taking a moment to plan your strategy. Generally, we recommend building your design up sequentially, going one by one through the functional requirements. This will help you stay focused and ensure you don't get lost in the weeds as you go. Once you have satisfied the functional requirements, you will rely on non-functional requirements to guide you through the deep dives. Okay.
Yeah.
Yeah, so it was just informational. Uh,
Yeah. Yeah. Move ahead.
Defining the core entities. Okay. So we are basically now moving ahead with the functional part, like how we will be designing the APIs and all. So at this stage, it is necessary to know to know every specific column or detail. We will focus on the indices later when we have a clear grasp of the system. This is basically the high-level design. Initially, establish these key entities will guide our thought process and lay a solid foundation as we progress towards defining the API. So,
Yeah, so if I think through it, so we are trying to find here the core entities. So
yeah.
basically, our flow would have two services. One is for the upload flow, and another is for
The
watching
stream. Yeah.
watching the video. Yeah. So upload flow or yeah, stream would be uh, yeah, it would be, yeah, stream would be a different flow. So
Hmm.
mainly how we are uploading the videos, that would be the it will have the size, the format,
Yes.
the quality of the video, and some metadata with respect to video, like the video ID,
Hmm.
or maybe the format and subtitle. So those metadata creation date time, so those are the metadata we can store
Mm.
separately in the metadata DB. And another thing, we can store the main data in some S3 or Amazon S3, which supports, because it's mostly a static data.
Yeah.
So maybe we can store it in S3 buckets. And yeah, so that is what I can think for the storage part. And if we see the live streaming, so live streaming is kind of similar to a Netflix design. So
Hmm.
where we can use something like a UDP protocol for it, and where we can for the streaming purpose, uh, we can I'm just thinking that how we will store, because we don't need storage for stream, or if we want a storage for stream, then
We do actually we do require a storage, I guess, because suppose we are suppose the streaming service is basically uh, so the player is fetching the data. for the upcoming chunk that he needs to pass to the user's video player that he will see. But suppose the user tries to go backwards, like he can just go 15 or 20 seconds backward also in the flow, right?
Mm-hmm.
And seek the pointer from there. So we need to give the data directly. So until to unless we cache it somewhere or we store that particular chunk somewhere
Mm-hmm.
in the S3 or somewhere, uh, the viewer will see a big latency in the video player.
Yeah, I mean, yeah, exactly. So, and so we need to store it in some chunks, and for example, we can have some offset assigned. We can
Yes,
break the video of length, let's say 1 hour, into chunks of 5 minutes or something, and we can have offsets assigned to it, and accordingly we can kind of stream it. Okay, makes sense.
yeah,
Let's move ahead. Yeah.
yeah. So we are having three entities: the user one, the video one, and video metadata, and which we are basically storing the information required for the video. So these are the three entities. Now let's move ahead with the API part. So we are having an upload API, which will basically contains the video and the video metadata. That
Mm-hmm.
will be basically, so I guess this API is being used to upload the video directly to the S3 or storage. That will help us.
Yeah,
Okay.
so it is a okay, it is a endpoint, but it is taking in the request some video and video metadata. Okay, so these
Yeah.
are kind of objects. Okay, and
Yeah.
stream would be a get API where you we are passing video ID and
And we will get video and video metadata.
in
Yeah.
response. Okay.
Be aware that your APIs may change or evolve as you progress. In this case, our upload and stream APIs actually evolve significantly as we weigh the trade-offs, various approaches in our high-level design. More on this later, basically. So you can proactively communicate with the interviewer by saying, I am going to outline some simple APIs, but may come back and improve them as we delve deeper into the system.
Mm-hmm.
Okay.
Okay.
So let's go for the video streaming. Before jumping to each requirements, it's worth laying out some fundamental information about the video storage and streaming that is worth knowing. Okay. To succeed in designing YouTube, you don't need to be an expert on video streaming or video storage. This would be an unreasonable ask. However, it's worth understanding the fundamental at a high level to be able to successfully navigate this question. Okay. So I know about this part, video codec. So it's basically kind of a like a encoder decoder thing.
Mm-hmm.
So suppose you have a file like a MP4 file.
Mm-hmm.
That is a suitable video format that can be used to display the video. But we can have other formats also.
Okay.
So I guess this video codec, what it does is it is used to transfer the data
Mm-hmm.
into some chunks, and that will be stored at a particular place, and then we can process the bigger file into the smaller chunks into a bigger file, and that can also be converted into some other format as well.
Yeah, so it's kind of a binary data, and maybe and that is and that data is like in the very optimized so that it reduce the size, and it kind of
Yeah,
low level kind of a data, something like that. Yeah. So time,
codecs.
yeah, codecs usually trade off. So I think there would be different these video encoder decoders that
Mhm.
and we can choose uh, on the basis of like the time required to compress a file,
Press a file.
how much it is reducing the size, and compression quality, whether it is the data is getting lost or not. So these are, I think, the examples which
Hmm.
encoder decoder we will use in our service for processing that video file.
Yeah.
Okay.
And we have video containers also. Video container is a
I
file
think
format that
the
store
yeah, I think
video
the same
frames.
thing can be used for audio files also, where we can
Yeah.
process the audio encoder decoders. Maybe yeah.
I guess this video codec is also used for select this H.264 and MPEG-2 and PPEG-4.
Mm-hmm.
These are used for audio as well.
Okay.
If you remember, like when we used to have this site like songspk.com
Mm-hmm.
where we can download the songs. I am talking about like 15, 20 years back.
Yeah, yeah, correct.
So in that time, we used to download these kind of format as well sometime.
Mm-hmm. Okay. Yeah.
A video container is a file format that stores video data, basically frames and audio and metadata. A container might house information like video transcripts as well. It differs from a codec in the sense that codec determines how a video is compressed or decompressed,
Mm-hmm.
whereas a container dictates file format on how video is stored. Support for video containers varies by device or operating system.
Okay.
Okay. Yeah. The bitrate of a video is the number of bits transmitted over a period of time, typically measured by kilobytes per second or megabytes per second. The size and quality of the video affect the bitrate. High resolution videos with higher frame rates, basically measured in FPS, have significantly high bit rates versus low resolution videos at lower frame rates. This is because there's literally more data that needs to be transferred in order for the video to play. The compression via codec can also have an effect on bitrate, as more efficient compression can lead to a larger video being compressed to a much smaller size in prior to transmission. Okay, so I guess it is saying like, so suppose we have a 1 GB of file,
Mm-hmm.
and in that, just to play the video, we need to transfer, I guess, 1 MB of the 1 MB of the data at a particular per second speed. But suppose this is a very big file and it's like a 10 GB of file, and then we are passing the 1 MB of data, then that is not sufficiently required to play the video. So this bitrate determines how number of bits per second we need to transfer so that the video can play. It
Yeah,
depends
and
on the size of the video.
yeah, and maybe because of maybe the network quality also of the user, right? So
Yes.
maybe it kind of optimizes on that. Like if the user has a uh, not that great quality, network quality, then it
Mm,
the bit rate would be different for it. And if the user has a good connectivity, then it would be different. But yeah, but it says that compression via codecs can also have an effect on bitrate, as more
mm.
efficient compression can lead to a larger video being compressed to a smaller size prior to transmission. This I didn't understand completely, but
I can also take. Okay. As more efficient compression can lead to larger. Okay, so basically it is saying the better the bitrate we will use, it will like compress or decompress the size, right? So
mm-hmm.
so we would require a lesser number of bitrate if we are using a better codec. As you can see, as more efficient compression can lead to a larger video being compressed to a much smaller size prior to transmission. So if we are using a codec and a good codec, and then we are trying to send the file or stream the file,
Mm-hmm.
we have to pass a lesser amount of data that we need to send originally.
Correct. Yeah, exactly. So if yeah, so bitrate would depend on the codec we are using. Uh, yeah.
Yeah.
Okay.
Manifest files. Manifest files are text-based documents that give details about video streams. There's typically two types of manifest files, primary and media files.
Mm-hmm.
Okay. A primary manifest file lists all the available versions of the video, like the different file formats, and the primary is the root file and points to media manifest files, each representing a different version of the video. Okay, so manifest files are basically text-based documents, and they are of two types: the primary and media files. And the primary manifest file lists all the available versions of the video. Okay, so I guess it is saying like manifest files are two types, and the first one will list out the different formats of the video that we have, like uh, MP4, MP3, or whatever,
Mm-hmm.
and the media one will contain the video. Each of the different version of the video. The video version is typically split into small segments, each a few seconds long. The media manifest file lists out all the links to these clip files and are used by video players to stream videos by serving an index to these segments. Yeah. So
Yeah.
basically, the primary manifest file will contain for the file formats that it will support, and the media files will contain basically the links of the videos that we have stored.
Yeah. So we can think of it as a file which kind of stores the information for like where the video for those video links as you
Mhm.
mentioned, and a video version is typically split into small segments, each a few seconds long. So there is some index, and we are dividing, I think, the information of the video in small segments, and that we are kind of storing it in this manifest file.
Yeah.
It doesn't make sense like why it is needed, but maybe we can see later like how it is being used.
I guess they are giving us the extension to
Mm-hmm.
also support the video processing in the future.
Okay.
I guess so, because mostly the streaming services generally support the video processing as well, because that is what most of the time requires. Like we have this functionality in the YouTube, right? Or in the most of the streaming platforms, like we can switch from 480p to 720p or vice versa.
Yeah, correct.
Those things, I guess, requires the video processing as well.
Okay. Yeah.
Throughout this write-up, a video format will be a shorthand term, okay, we use for referring to a container and a codec combination. Okay, now just let's jump into the functional requirements here. So basically, the video format will consider the video container that is storing the file and the metadata, and the codec, which is basically just the small chunk that is being transferred
Mm-hmm.
from the backend to the front end. One of the now let's we are at the upload videos part. So one of the main requirements of YouTube is to allow the users to upload the videos and eventually viewed by the other users. Okay. So when we upload a video, we need to consider a few fundamental things. Where do we store the video metadata? That is the name, description, etc.
Mm-hmm.
Where do we store the videos data like frames, audio, etc.? And what do we store for video data?
Yeah.
Okay.
So I think the first thing can be stored in like something like a NoSQL store or
Yes.
because it is a metadata. And even I think we can store it into MySQL also, but because we need high availability, so and
Hmm.
this doesn't require uh, any consistency, and even this metadata is kind of unstructured, where you would have a video and different parameters. So
Yeah.
so it's makes sense to store it into NoSQL. So maybe we can use Cassandra or DynamoDB for it.
Yes.
And where do we store the video data? So video data, I think, is
I'm
the
actually confused in here. Why are we saving the frames and audio at a different place? We can have a just like we can store the videos directly, right? Like in the S3, we can just directly store the video data. Why we need to like separately store the video data and the other data like frames, audio, and etc.
uh, okay. So maybe this is maybe for streaming, and once, let's say, a stream gets completed, then the entire thing would be stored in video data. This is what I am guessing, that maybe we need to store some chunks, and when the user is seeing, then we are sending those chunks, but the entire data, which would be more highly compressed or something, we can store that separately.
Yeah, might be. Okay, let's move ahead.
Yeah,
I guess
let's.
we will get the answer in the
Yeah, yeah.
later part. For the video metadata, we are assuming an upload rate of nearly 1 billion videos per day. This means over the course of the year, we will have nearly 365 million records in the database
Correct.
representing videos.
Mm,
As a result, we should consider storing videos metadata in a database that can be horizontally partitioned, such as Cassandra.
yeah.
Okay, so video data, metadata. Okay, yeah,
Yeah.
so they are basically using the NoSQL database. That is the correct thing. Cassandra offers high availability and enables us to choose a partition key for our data. We can partition on the video ID since we are not really worried about bulk accessing videos in this design, just querying individual videos.
Correct.
Okay,
Yeah, this is like straightforward. So yeah, we can move ahead. Yeah.
yeah. When designing a data storage solution that needs to scale, it's worthwhile to think about partitioning. Some systems necessitate careful partitioning such that the data can be read from a single or handful of nodes. I didn't get this part. Some systems
Yes. So
necessitate careful
basically,
partitioning.
you have to make a decision, like how would you partition, on what basis, right? So if you
Okay,
see Cassandra, then there would be different servers. Okay, so there would be
okay.
different nodes. So what would be a key, partition key? So generally, that partition key, uh, through that partition key, you decide like where the request, if it is coming, then which
Mm-hmm.
server it will route to. So if, let's say, that if you choose the wrong partition key, and it becomes a hot key, so then all the requests will end up on a single node, and that can bring down your system.
Okay.
So generally, partition key is chosen a mixture of two keys, or maybe a single key can also, but they have chosen here video ID. So they will justify it, like if you read it through, then they will justify that why they are using it.
Okay. Other systems require consistency within the within some scope domain, necessitating a relational DB, which asset guarantees, sharded by a key that represents a domain. Example, ticket master might be sharded by concert ID to ensure consistency of ticket purchases. However, there's some systems that don't require careful partitioning at all. For this system, we can sort by video ID because we had only ever to do a point lookup by the video ID. Okay.
Yeah, so video ID would be unique, and so the request would be we can shard it that some, let's say, 1 to 100 video ID will fall in server 1,
Mm-hmm.
101 to 100, 201 will fall in server 2. So it's kind of a hash ring where you will say that if the video ID is between this range, it will fall in server 1. If it is in another range, then it will fall on server 2. So it is kind of evenly distributed. And yeah,
Yeah.
and how it happens, how it will be happening is that let's say then there is a problem, right? That if, let's say, your one node
Mm-hmm.
goes down, then you lose the data. So that doesn't happen because Cassandra uses a gossip protocol where each node knows about every other node, and also it maintains replicas of the data. So,
Okay.
and once it maintains the replica, then uh, if your node goes down, still other nodes would be knowing like which replica they can refer. So I think that's how video ID makes a good choice here.
Yeah. For storing video data, we can see some overlap with this problem. Okay. The TLDR uh, is that it's more efficient to upload data directly to blob store like S3 via pre-designed URL and with the multi-part upload. Yeah, that is what I was thinking.
Hmm.
Because S3 provides us a multi-part upload, which is basically the multi-threaded way of storing the data
Okay.
in the chunks. Feel free to read our write-up on Dropbox for an analysis of that part of the system. Yeah.
Okay. Yeah.
Yeah. So this multi-part upload is basically the same thing that we do in the multi-threading. Just like uh, it will dissect the whole file into some smaller chunks, and then it will try to upload the chunks by the given threads. And if the first thread successfully completes this part of first, then it will come. Then the next segment will be bisected into smaller segments, and that will be processed
Mm-hmm.
like that.
Okay.
To design decision to upload S3 means we have to change our post upload API to a post pre-designed URL API. The server will create a pre-designed URL to enable the client to upload directly to S3. The request payload will just be the video metadata versus the metadata and the video file. Okay, so this is basically the diagram of the architecture that we have. Basically, the client would directly have a pre-designed URL for the S3, and there would be a API gateway with the in between the video service and the client, which will basically do the routing, authentication, and rate limiting as well. And it will pass the pre-designed URL, it will take from the S3, and then all the video metadata would be stored in the video metadata DB, that is Cassandra, and the storage would be on the S3. The video would be on the S3, but metadata would be stored on the Cassandra.
Yeah, but it is making a post call also, right, to the pre-assigned URL.
Yeah,
If we then where is that encoding decoding logic happening? Is it happening in the video service? I guess maybe.
actually, I guess that part happens when we stream the video, not in the uploading part.
No, it happens in both the things because
Oh,
you
okay.
would have different formats, right? Again, the same
Mm-hmm.
thing. So that encoding and bit rate, those things should be done before you actually upload the data. So So I think first thing is that they will get that S3 bucket, uh,
Yes.
and then it will be talking to this pre-signed URL also for posting the data. So maybe they were talking, right, the 2 and 3 points. So I
Yeah.
think if you scroll up, right, so where do we store the video data, frames audio, and where do we store the video data? So
It is what do we what do we store for video data and where do we store the video data? So this one, like we have the answer, we will store in S3. And now what do we store for video data?
hmm, okay. Okay, fine. Let's move down. The design decision to upload S3. Can you scroll up? Yes,
Yeah,
means we have changed upload API to this. The server will create one URL to enable the client to upload. Okay, so maybe that is a get call, but why that post call is happening? That is what I am thinking. Maybe they are talking about it down. Let's check.
I guess they are saying earlier we had this upload a post call that will be changed to this pre-designed post call that will contain the metadata as well as the video. And in this video service, we will store the information of the metadata separately, and the video will be stored in the S3.
Okay, okay, fine. Yeah.
Okay. And here they have the solutions to what we were
So,
thinking. Like
yeah, finally, when it comes to storing the video, it is worthwhile to consider what we will be storing. Understanding this will help us clarify how we will process the videos to enable system for our functional. Okay, yeah, we can go through the solutions here.
the bad solution, the approach. This approach basically ignores the fact that we will need to do any video post processing. We store just the file the user provides and don't perform any post processing. Okay. This The challenges are this is a native design and that won't work in practice because different devices require different video formats in order to play back video. We need to be more sophisticated when it comes to how we store videos. Okay.
Okay. Yeah, I think we don't want to store the raw video. We have to do
Hmm.
some post processing. Uh, uh,
Yeah. Because different devices require different
yeah,
formats.
yeah, yeah, yeah. Let's move on. So
Yeah.
this approach involves doing some sort of post processing of a video to ensure we convert the video into different formats playing on devices. Once the user uploads a video, S3 will fire an event to the video service.
Video
Uh,
processing service.
yeah, video processing service. This service will do convert the original video into different formats, and it will store each format as a file in S3. It will Okay, it will store each format as a file in SD. So
Hmm.
every format would have a
Different
different
file.
file. Exactly, yeah. It will also update the video and with the file URLs representing the different formats. So this is fine. So there is a video processing service. So once it is uploaded into S3, then S3 will fire a notification to this video processing service, which will do processing and store it in different formats back to the S3. Okay.
Okay. But I have one question. So, suppose in YouTube, I try to upload a particular video, then it takes some time, right? And then it lets us know, okay, now your video is ready to play. Like now it has been stored, and now you can play the video, or it can be premiered to the other users as well. So, if it is storing the video in the S3
Hmm.
and then sending an event notification when the video has been saved. And then this video processing service is basically converting that format into different formats and then trying to store in here. Then
Mm-hmm.
we should have another API, right? That will give us the status that to the client that now your video has been uploaded once this part of the storing of different formats has been done on the S3.
No, so I don't think that your video processing part is dependent. Client doesn't care, right, how you store the data.
Yeah,
So it would be a background process which you would be doing. So why would you stop the client from uploading for your optimizations? Okay, so that optimization you can do later also, right? So that is why I think they are putting everything, dump everything on S3, and how it is actually being stored is decided later. It's not happening real time. So it will kind of it will do some processing and different formats that can take significant time. So you don't
yeah,
want the user to wait for that long, right? So
yeah.
that is why I think that is why they are calling it a post processing process.
Hmm. Okay. And so, along with the videos saved into different formats in S3,
Mm-hmm.
we are basically also giving the information of the new saved formats into the video metadata
Correct. It
from
will
the
have
video process service.
so S3 would have n number of formats, and similarly video metadata would also have these formats, because S3 URLs would be different.
Yeah.
So that is why there would be n number of entries in video metadata also
Hmm.
for a given video ID. Yeah.
Okay. Let's check the challenges for this particular solution. The approach fails to anticipate the need to store small segments of video for streaming later. If we store the entire video, there's no way for the client to download part of a video, as we will see later. Downloading part of a video is really important for streaming for various reasons.
Okay.
Yeah, that makes sense.
Mm-hmm. Yeah.
Now let's look for the third one. This approach post-processes video by splitting them into small segments, each playable unit that's a few seconds of length. Yeah, that's what we talked about, right?
Mm-hmm.
In here, bitrate and all.
Yeah.
And then converts each segment into different formats playable on different devices. This is a strictly better design than the previous design because it enables more efficient video streaming later, which we will clarify as we discuss our design.
Okay.
Okay. So basically, does it mean that we will store the chunks in the S3 rather than the whole, combining the whole video content into one?
Yeah, I mean, but how would you say that you can store the chunks, but then you would need some chunk ID or something, right?
Yes.
Maybe in the uh, like, how would you store that information for chunks? So maybe we can, if we can store that, then we can have that logic where we can have multiple IDs of chunks for a
Mm-hmm.
given video ID, and
Mm.
store that in S3, and then S3 somehow knows that for a particular video ID, what are the chunks, or
Yes.
uh, then it picks it up and arranges them in a sequence so that it can be played.
Okay. Uh,
Yeah.
so here we have this pipeline that splits up a video, convert each converts each segment into various formats.
Hmm.
I guess and store different video formatted segments. Yeah, I guess we are just uh, splitting it to different segments only. We are not combining it to a bigger large file.
Yeah, they have kind of divided it further. I mean, earlier, like for we are divided in into different formats. Now each
Mm,
format they have again divided it into chunks.
yes.
So, but one doubt I had was about uh, uh, I just forgot it. So maybe yeah, we can move on. Like, uh,
Okay. This approach introduces some complexity. Firstly, it makes our processing service more complex, turning it into a pipeline. It must fire it sorry it first must split the whole video into segments and then generate video formats per segment. In addition, the system needs to store references of these segments in a sane way and use them downstream in our streaming flow efficiently. This will be a key system to clarify when we get go on the deep dive portion of the interview. Okay,
okay,
so I guess during the streaming part, they will let us know how they are basically storing the segments, like what is the way of their storing these segments that
yeah,
we
yeah,
can find which segment to display.
hmm. Yeah, okay. We can move on. Yeah.
Yeah, users can watch videos. So okay, so now that
Yeah, I think
one
it
second.
is fairly simple. Like once you will make a get call, you will get the video metadata, and that video metadata for a
Yeah.
given video ID, you can get those chunks from the S3,
Hmm.
and it would uh, it would just return you that response. So
Yes.
that is
The
what.
first
Yeah.
part, I guess, we don't need to see as it is saying like we will download the whole file that we are not going to do anyways. And we have stored the data in segments already. So we can go for the second solution.
Yeah.
Rather than forcing a full video downloader at once, the system can download instead video segments to properly stream the video. This client would choose a video format based on the user's device, like bandwidth and the preferences. If the user specified HD video, the client should stream 1080p video. The client would then load the first segment of the video, which would be a few seconds in length. This would allow the user to start watching the video quickly without excess loading. In the background, the client would start loading more segments so that it could continue playing the video seamlessly.
Yeah, I mean, yeah, that is fine, and even this fetching of the data can happen asynchronously also, right?
Hmm.
So,
Yeah.
and just when we get the data, we can present that to the user in sequence order, but we can fetch those chunks asynchronously and keep on arranging those chunks in sequence.
Yeah, actually, what I have seen, so suppose we are at a particular point, let's say at 3 minutes, 3 minutes 30 seconds.
Hmm.
So when we reach to a particular point, what the player tries to do is he tries to call for the data of the next 10 seconds,
Okay.
and it divides the whole 10 seconds into 10, 10 small chunks. So it requires to like it sends the request to get the data for the each second, and that's how it works. And this happens in both the ways, like either you are just locally streaming the video or through any server.
Okay.
This is the default behavior that a YouTube player has.
Yeah, yeah, I agree to that. Yeah. So,
Okay.
yeah, we can move on.
This approach is more complex and relies on the uploaded videos being stored as segments, which was previous designed. Additionally, this approach doesn't take into account the fluctuating network constraints while a user is watching a video. If a 1080p video is streamed and network conditions get worse, loading 1080p segments might get slower, resulting in buffering for the user.
Okay.
On the surface, it may seem like the good approach, just like the chunked download of the video, but it is actually a distinct approach and strictly better or more clear. Some video formats could be stored in order, meaning download the file in chunks, that is 5 MB at a time. It will result in a file stream that is actually playable. However, this isn't always the case for all the video formats, and it might be unclear to the interviewer that this approach is actually resulting in data that can be played back to the user with a quick turnaround time, because the solution involves diving a video into playable segments. It more clearly conveys the means by which the video can be quickly and incrementally played, and it's strictly closer to the great solution below. So we basically have covered a good solution, but it's not great because there are some problems in here, like the above thing that we have discussed, like the 1080p thing.
Mm-hmm. Yeah, that
And
is like the first approach is of dividing into chunks and then reading it through, and the second would be more about the bit rate and how do you process.
mhm,
So so basically, first part, if you see, right, so it was
mhm,
encoding part, and
yeah,
another, when you are trying to get the video, that is a decoding part. So that goes hand in hand, right? So
mhm,
if the first solution talks about chunking and segments and bit rate, then
mhm,
our get API will also behave in the same way, right?
yeah.
So I think that is what they will be talking about. We can just quickly wrap it up. Yeah, the adapted bitrate.
Adaptive bitrate streaming relies on having stored segments of videos in different formats. It also relies on manifest file being created during
Video
video upload
upload
time,
time.
which references all the video segments that are available in different formats. Think of a manifest file as an index for all the different video segments with different formats. It will be used by the client to stream segments of video as network conditions vary. See an example here. Okay, I guess now it is talking about the, oh, okay, HLS is streaming. Okay, I guess it is. I guess we can check for it later.
Yeah, yeah, it
Uh,
is fine. Yeah, we can. So basically, in manifest file, you are storing everything. So it's kind of your source of truth, and it knows information about each segment and format. So, and on that basis, I think they are trying to decide something which they are talking about later. So they are deciding that the client will execute the following logic when streaming the video. The client will fetch the video metadata, which will have a URL pointing to manifest file in S3. So, so this is correlation with respect to the manifest file. So
yeah.
the client will fetch the video metadata, which will be pointing to the manifest file in S3. So on that, basically it will use manifest file to fetch those formats and
Mhm.
chunks, right? And client will choose the format based on network conditions. I'm not sure if YouTube actually uses this approach, but yeah, we can, it's just kind of some design where they
Yeah.
are dumping everything into a file.
Mhm.
So even Redis and other things also keep that append only file, right? So
Yeah.
many systems actually uses this file based thing.
Mhm.
So the client retrieves the URL for the segment In chosen format, the client will download the first segment. The client will play that segment, begin downloading more segments. If the client detects that the network conditions are slowing down, it will vary the format of the video segments. Yeah,
And
obviously, like if it is slowing down, network conditions are bad, then it will refer to
mhm,
another format.
yeah.
So this makes sense. I think just that one layer of manifest is introduced, so they will
Mm.
be using manifest.
But they haven't give any.
They are talking about the download segments, adapted bitrate.
They have just added this get video thing in here in the diagram, and they haven't introduced anything because I guess that part of the checking for the file in the for the this particular
Hmm.
manifest files that will handle from the client side, I guess.
Yeah, I think yeah, client can use that file. It will download that file. The client, if
Hmm.
you see third point, right, second point. So client will download the manifest file, and
Yeah.
on it will try to process it and see like which segment to download.
Yes. Okay. The challenges. This approach is the most complex and involves the client being a more active participant in the system, which isn't a bad thing. It also relies on upstream design decisions involving video splitting by segments, variants of format storage, and the creation of manifest files.
Hmm.
Okay. And now potential deep dives.
How many deep dives are there? If there are more, then maybe we can take that tomorrow.
I guess, yeah, because it will be too much to consume in a day,
Yeah,
and there are a lot of.
yeah. There
Okay,
are, I think,
please.
three deep dives, so it will take around half an
Hmm.
hour or more. So maybe we can take this up tomorrow and we can proceed
Yeah,
because there are a lot of text also which we have to check.
yes.
Okay.
Now they're also talking about the video processing and all. You can
Hmm,
see
yeah, that is
FMPEG and all.
that is in detail, right? So we
Hmm.
have covered, I think, the upload and the download flow. Now we will
Yes.
be diving deep into like how that is actually happening.
Hmm.
So that I think we will discuss and yeah, I think we had a good discussion. Maybe tomorrow we can wind it up. Yeah.